I want to get you guys rolling on the
group thing.
Yes.
I had an idea about that. Instead of like getting a group with your friends, maybe raise your hand about which one you find interesting. That way you get people that also.
Okay. Yeah. We'll do that. We will do that. We'll sort into groups. But before you sort into groups, I want to give you guys some information about what this project is about. So, and the reason I want to get this started, I want to start this as soon as possible, is because this project is going to require high-frequency sampling, and I want to start it as soon in the year as we can. I don't want to wait too much longer. But yeah, there's the vaping project. There's this. There's the cyanobacteria that some of you guys worked on, and whatever. And then there's the opportunity for other independent projects. Second semester, this semester, I'm going to get us started on some of these projects, particularly ones that are going to require sampling now. And then I'm going to just lecture. I'm going to hit the A&P lecture as hard as I can until Christmas. And then next semester, because I can't come, and that will set you up for January, where I will drag you guys into the A&P class at Colby as much as I can. You'll present what's called the Grand Rounds presentation there, and I'll explain what that means. And then you'll be working on this independent project for the second semester, and I'll meet with you guys on Tuesdays. I will not be able to be here on Thursdays, and I won't be able to be here every Tuesday either. So there will be weeks when you don't see me at all, and that's just the reality. But I want to get you guys as independent as possible, all right, on projects that are going to be fulfilling for you, all right? So one of them is arsenic. And you may ask yourself, so the PowerPoint that I'm about to show you is a PowerPoint that was presented to this conference that I set up last year. It was presented by Callie Lazada, Trinity Hutchins, for those of you who remember her, and Alea Perry. No, she didn't come. It was Alyssa Bennett. It was Callie, Alyssa, and Trinity. All right, and this was a slideshow that they put together with my help, and they presented at this conference downtown in Waterville at the Chase Forum there. The basic question is why. So this whole project, the way I worked it with them, we would come up with questions. We would just have discussions, and there would be a question, and then we would see if we could answer that question. Right? We would form hypotheses, and we'll get to what that means in a bit. But one of the questions that Alyssa had in the very beginning was, okay, we're talking about arsenic. We're doing this arsenic sampling. Why is it a problem? Is arsenic a problem? What do you guys know about arsenic? Anyone? Yeah. It is. Yeah, it's carcinogenic. There's a lot of things that are carcinogenic, aren't there? Give me an example of a carcinogen. Arsenic. What's something else that causes cancer? Come on, you guys know this. Anything. Just pick one. There's like a zillion things.
Vaping.
Yeah, vaping probably does. And certainly cigarettes do. Processed red meat causes colon cancer. Smoking causes lung cancer. What are some other things that cause cancer? Yeah. Too much exposure to UV light can cause melanoma, skin cancer. Yeah.
I actually heard there's some like candies that you can eat.
Sure. Yeah. But potentially, certainly a lot of things we eat cause cancer. For example, basil. Did you know that basil is a carcinogen? Not a strong carcinogen, but it causes cancer. As does mate tea. Yerba mate tea causes pharyngeal cancer. I still drink it sometimes. But, so yeah, it causes cancer. what kind of cancer, how, so that could lead into a lot of these other compelling questions. What sort of cancer? What's the exposure level that leads to cancer? What's the incidence? What's your chance of getting cancer? People have been eating basil for years, and people aren't dropping dead of cancer left and right from basil, but it happens, I guess. So how carcinogenic is it? What are some other problems with arsenic? Is it just that it causes cancer? What else do you guys know about arsenic? Anything? No? Well, we'll go through some of this right now. It's a poison. It's toxic. It actually, you don't have to wait to get cancer for arsenic to mess you up. So here are just a few of the effects on the human body. It has a direct effect on the nervous system. So it is a neurotoxin. It can impair your motor function. By motor, I mean your bodily motion, your ability to use your muscles. It can lead to neuropathy. This word is neuropathy, and it just means PATH. The word, when you see PATH in a medical word, it refers to pathology or something that's wrong, pathogenic, something that is not right with the body is a pathology. So neuropathy is something that is wrong with your nerves. It causes nerve dysfunction, and it impairs intellectual function. In fact, it has been shown to, and I'll show you some data in a little bit, it impairs cognitive development in children, which is an interesting consideration when you think about what is the effect that it's having on young people in the state of Maine, and if it's consistently suppressing cognitive development in young people in the state of Maine, what does that do to the economic future of Maine? What are the human and economic and social costs of that? People with impaired cognitive function have aberrant behavior that gets them in jail or gets them making poor decisions, life decisions, right? So it does impair cognitive development. So that's just the nervous system. Effects, chronic exposure to arsenic has been correlated with coronary heart disease, hypertension, or high blood pressure is what that means. High tension is the tension of blood in your cardiovascular system. Cardiovascular just meaning heart and blood vessels. And it leads to heart attacks. Your renal system, that is the kidneys, and the system that produces urine. It causes kidney cancer and bladder cancer. I'll show you some data in a little bit, but the state of Maine has 800% higher. That's 8 times the national average of bladder cancer. So that means 2, 4, 6, 8. If there was one person in here that had bladder cancer, right, from across the United States, that means that if it was a group of people in just the state of Maine, and this is a bit of a specious argument, I don't want to do this because that would be 12%, and that is not the actual difference. But it would be 8 times higher than that. It would be virtually everyone in the class. It's just certainly a problem, bladder cancer. It causes skin lesions, various types of skin cancer. And so all of these different effects depend upon the mode of exposure, right? Skin lesion, skin cancer is through direct contact with the skin. Bladder cancer and kidney cancer, how would you guess that you would be exposed to the arsenic if you're getting bladder and kidney cancer? Drinking it, yeah. It has been correlated with the advent of diabetes, and it's messing up women's glucose tolerance in pregnant women, which leads them to have diabetes later after postpartum, after the baby's born, but can also lead to metabolic abnormalities in the child, the baby that is born. The respiratory system, it can lead to pulmonary tuberculosis, so not bacterial tuberculosis, but it can lead to an inflammation that looks like bacterial tuberculosis in the lungs, in the tubercles, in the little tubes of your lungs. You have an osis, often means some sort of, again, like a pathology. Bronchiostasis, impaired ability to breathe. It can also lead to lung cancer. So all of this is through aspiration. If you were to somehow breathe the arsenic dust, it can lead to liver cancer, and then developmental processes. So I guess this goes along with the nervous system. Increased risk of cancer as adults, of widely distributed types of cancer, increased infant mortality, neurological impairment in children, and reduced birth weight. So arsenic is pretty nasty shit, right? It's pretty nasty stuff. Well, I guess before I go into that, they don't have this in their slideshow, but arsenic has often been a poison during the Victorian era. If you wanted to get rid of somebody, you'd get yourself a little jar of arsenic. It was easy to go to the apothecary and buy yourself a little jar of the stuff. It has no flavor. It's pretty easy to bake into a cake or something like that. And you would feed it to someone. Yeah. Sure, but if you have murderous intent, it seems like you are not thinking things through very clearly in the first place. Yeah. So, but it's going to have less of an effect on you just being around it than it would be for the person you're feeding it to. Acute exposure. Acute. So there's two types of exposure to toxins. What's that? There's acute and chronic. Acute exposure means like very focal event, like high exposure to a high amount of this shit right away. Acute exposure. Versus chronic. Chronic is like long-term exposure to little bits day after day after day. Acute and chronic exposure. Acute exposure is not actually what happens in Maine, but let's see what happens with acute exposure. This kind of nasty shit can happen. You can get cancerous lesions on the hand that you see on the left there if you touch the stuff. Get acute exposure that way. What's called nodular hyperkeratosis. So nodules, little bumps. Hyper meaning above keratosis. Keratin is the protein that is made in your skin that gives your skin its toughness. So hyperkeratosis is a thickening of the skin, a nodular thickening of the skin. And so you see that on the bottom of these people's feet who've been walking through it. Bangladesh, the country of Bangladesh, has been heavily contaminated from anthropogenic, man-made sources of arsenic, like heavily contaminated. Here's the country of Bangladesh. What a freaking nightmare this is. So it's been a bit of a case study, a bit of a grim natural experiment, a grim laboratory for seeing exactly what happens to a population when they have acute arsenic exposure. And you can see here that the concentration, the density of wells that have been contaminated with arsenic throughout the country of Bangladesh, which itself is like Maine would easily fit in this country. So pretty widespread. A lot of people live in Bangladesh, so it's a real problem. So in this population of Bangladeshis, they were able to document and actually find the direct mathematical correlation between urinary levels of arsenic. So they get the kids to pee in a cup, and they measure the level of arsenic that they find in their urine in micrograms, like so 1 millionth of a gram, And to give you a sense, a paper clip is about a gram, so a small paper clip. So 1/1,000,000th of that weight in a liter of your urine is what we're looking at here. That's that unit. So measuring arsenic in their urine, and it actually goes quite high. Some of these kids had super high levels. And then they looked at 0 being the baseline for that age group, the median IQ, and they looked at correlations between a loss of IQ points in these students. So for 9 and 10-year-olds, they had a total N of 143 plus 61 plus 28. That's about 230 students that they made these measurements on. And then sadly, look at that, in age 4 and 5-year-olds. I mean, these are kids like this big, right? Same thing is happening here. We're getting as much as 20 to 25% drop off in the IQ. And then the low IQ range here, there were 112 kids in this cohort, right? This study alone had 112 kids that were going to be down in here somewhere. So their IQ percentile, I mean, you're looking at 57th percentile, plus or minus. So the effects are cumulative. And one of the things that you notice going from here, the high exposure rates, they were down at about 22, 23%. Whereas by the time they get to 9 and 10 years old, we're down here at like 28 points off their IQ percentile. So, all right. You cool? But in Maine, the state of Maine, it is not acute exposure. It's chronic exposure. Yeah, nobody's coming in contact with mega doses of arsenic in the state of Maine. Yeah.
Oh, how is IQ?
An intelligent quotient is just there's like a test that they give a person that, and then there is like a normal distribution of people who perform on that, and you are scaled based upon that. So like, 100. I don't actually know a whole lot exactly about it, but 100 is meant to be the normative value. So like, yeah.
My question is why they I don't know if I heard that right, but did they do the IQ tests as well on the 3, 4, and 5-year-olds?
Yeah, 4 and 5-year-olds. Yeah.
Okay.
Yeah, you can do IQ tests on little kids. It's scaled to age.
Okay.
Right, because it's just like normative value for the people that age.
Oh, okay. Like what they should know at that.
Yeah,
age.
So there's going to be a distribution like this, right, of people who are going to perform on a test, and 100 is the normative value.
Yeah, no, I was just a little confused. They're like doing IQ tests on like 3-year-olds, and they're like, yeah, you're not that smart. Not that smart.
It's just looking at where it's like a comparative value. IQ is a comparative value. When you hear a person has like 120 IQ or 95 or whatever it is, that's just comparing the intelligence quotient to the general population. Okay. All right. In Maine, chronic exposure is the real problem. So here we have the map of bladder cancer mortality rates from white men and women by state, and broken up into economic zones. So like counties or whatever. Not just counties, but sometimes there are these economic. So Maine and Vermont, in the study, they report a positive exposure response relationship between arsenic intake and drinking water, arsenic intake from drinking water and bladder cancer. So this has been documented. In 2018, this paper came out just last year, not even a year ago. This study concluded not even a year ago. but the state of Maine and all of New England, because of its geology, and also Nevada, are hot spots for bladder cancer. And so when we look at a map showing the level of private domestic well users, people who are getting their water from wells, private wells, rather than municipal water, we see that these maps correlate really highly. All right, so high levels here in New England, and then across here, there, it goes down. But if we look, it's the same area, these same areas that have high incidence of people drinking water out of their wells. They're drinking this chronic toxin. It's not in municipal wells because the federal government, the EPA, hasn't been completely gutted yet over the last 3 years. There are clean water regulations that stipulate what a municipal water supply has to abide by in terms of minimum or maximum arsenic levels, right? But Maine, in particular, is one of many libertarian states that are libertarianly inclined, where people do not want federal regulations imposed upon their private use of wells. And because of that, there are no regulations around how much arsenic is allowed to be in a well that you might dig or drill or whatever for it to be potable. So this is why it's a well water problem. And that's this statistic here: 63 million Americans, nearly a fifth of the United States, from California to sea to shining sea, were exposed to potentially unsafe water more than once during the past decade, based on EPA data. Okay, so 1 in 5 Americans have drank water that is unsafe to drink. You shouldn't have drank it in more than once that you've done that during the past decade. And that is data that was published in 2017. That means there's people in this room that can claim that. And in fact, it's probably more than 1 in 5 in this room, given the actual distribution. This is a real problem. Bladder cancer, potentially cognitive impairment in young people, all these other problems that I initially talked about. So here is a map on the right-hand side of that was generated by the U.S. Geological Survey, which is a government agency. And what they did is they had well water testing data from across the country, and they correlated it with what was known about the geology in the country, and they produced this map right here that is a prediction of the likelihood of arsenic in your well water, based upon these EPA well data and geological modeling. So obviously green is low probability, and red is a probability of higher than 50%. What do you notice there about the state of Maine? It's pretty hot spot. Pretty hot spot. Yeah. And what we're finding out, what we found out last year, this map, it comes from actually kind of old data that was not especially thorough. What we're finding out is that this EPA, the original EPA data, predicted about 8% of wells in Maine had high arsenic levels. And but the data that we've been collecting as part of the SEPA grant that I'm going to talk about in a minute has been a much larger data set.
So it should be more than that.
Yes, it should be much more red than that. And the actual number in the state of Maine, widely distributed across the state, is between 18 and 20%. Right. So this map is not accurate. It's not accurate. The problem is worse than this, is what I'm saying. Okay. So it's a complicated problem in the state of Maine. Socioeconomics makes the problem worse.
I have a question.
Yes.
Is it just like the state of
Yeah, Maine has got it. What's that?
The
Nevada.
This area has got it bad. I probably
Yeah.
should have known which state it was.
Yeah, that's Nevada. And if we look back, we can see that Nevada is definitely a hot spot, and it's because of the geology in Nevada. Yeah. The thing about Nevada is that population densities in Nevada are relatively low compared to, so Maine is also pretty low, but New Hampshire and parts of Vermont, just the totality of it, more people are actually affected in New England than are affected in Nevada. Nevada, pretty much people live in like 2 cities in Nevada. They're either in Reno or Las Vegas. But in the state of Maine, socioeconomics makes the problem significantly worse. So when we look at this plot on the left, people who report, percentage of people who are reporting that arsenic is a problem are, if you have a bachelor's degree, if you have some level of educational attainment, you're more likely to think that arsenic is a problem than if you didn't go to college. Consequently, if you had some higher level of educational attainment, you're much more likely, at least twice as likely, to treat for arsenic than a person who didn't. Still, this is only 20%. 1 in 5 people in the state of Maine even think that it's a problem, right? Only 15%, that's about 1 in 7 people in the state of Maine treat for this. All right. So, yeah, we can get to there. We'll get there. So now this is on to the CEPA dataset. This is the actual data that my students last year, in conjunction with other high school students across the state that are on this grant, this SEPA grant, they began to collect some data, actual well data, to get a bigger data set. And this year my goal is to blow the collection that has been done previously out of the water. Out of the water. I want to get seasonal variations and be able to parameterize that in the trig class so we can take it to Augusta, to lawmakers to help influence policy. That's what I want to happen. And we can do it. We've got the money's in place right now. It's just like the willpower to do it, right? We've got a body of students that are, their families are, at least their communities are affected by it. And we're, it'll be a learning experience for you guys. This is an important project. So last year, the SEPA dataset collected 1,079 samples across 4 New England states, and Maine Arts Academy only collected 18 samples. But what was interesting about the Maine Arts Academy samples that we collected last year is that of any of the high schools out there, because we're this charter high school, they were by far the most geographically widespread of any of the samples in the data set. So MAA was able to cast a really wide geographic net, which was kind of interesting. So this past sampling round was really important for the region because there was a much higher percentage of wells that had not previously been tested for arsenic. So here's Hancock County. This is Mount Desert Island, like Acadia. This is the Maine coast here. and that's in Hancock County. It's outlined in green. This had been sampled quite heavily in the past because this SEPA grant is based on a previous grant that was run by the EPA. SEPA is through the National Institute of Health, so the money's coming through a different source. But the original EPA grant focused here in MDI, and they said, oh shit, there's a lot of arsenic up here. They're like bladder cancer rates are through the roof out there in Hancock County. But there was not a lot of sampling that had been done in Kennebec County previously. And as you see here, so half of the people that sent samples in from Kennebec County, and this, in all these data points, this is Maine Arts Academy and Waterville High School. So I am working with a guy at Waterville High School, two faculty there, a guy named John Ramgren and Justin Bureau are the two faculty at Waterville High School. And it's a bigger school, and they also have a bunch of samples throughout this region. They're really clustered here. Maine Arts Academy is sort of like the widespread samples there. But it was really important. It was an important round of sampling for the state. And right now, out of all of the data points in the state of Maine, just these two counties are 92% of the samples in Maine, 97% if you count just a few samples that are over the border in Somerset County that Maine Arts Academy contributed. So most of the data in Maine is in just these two little regions. The vast majority of the state has not been properly covered by sampling yet, which is another huge problem. It's a huge problem. All right. So if you look at Kennebec County, the mean here is 4.6. So the magic number, let me give you a magic number. It's 10 micrograms per liter. That is the EPA limit, right? Anything above 10 micrograms per liter of arsenic, that concentration is deemed to be toxic by the EPA. That number is already too high, right? That number is already too high because I talked about how arsenic is actually a chronic toxin as well as acute toxin. Chronic exposure to arsenic, you probably shouldn't be drinking any of the shit. You probably shouldn't have any of it coming in because it's a cumulative chronic exposure issue. But the mean in Kennebec County is 4.9 essentially. The median, you guys understand the difference between mean and median? Who does not? Everybody's good? Do you know why you look at a median versus a mean? What does a median tell you that a mean does not? Yeah, B. Thank you. Good girl. That's right. So a mean, you can have like a really high number somewhere, like a strong outlier that will throw your mean off. But if you look at the middle value, it's not affected by outliers. And if you see here, there was a max value. Some well in Kennebec County had 64 micrograms per liter. That is super toxic, right? That is super toxic water. It's toxic for chronic exposure. Drinking that does not go into the acute exposure range. I mean, it's a good question. That's something that you should certainly, the next round of students, that'll be part of your investigations. What is the minimum threshold considered for acute exposure? What is that, right? Because there are wells in Hancock County, look at that, holy shit, 234 micrograms per liter. They're like drinking really high arsenic in that water, right? I mean, that's 24 times, almost 24 times the maximum level allowed by the EPA in municipal water, which is already too high, right? Okay. Their mean is above the limit. That's crazy. It is being thrown off by these max values. All right. So all of this question, I guess before I get to that, there are so the takeaway from this, there are high levels of arsenic across the state, not just on the coast, not just in MDI. It's throughout the state, and that's because there's bedrock everywhere. I mean, there's a chunk of frickin' bedrock right there. I look at it out the door by that birch. It's under the ground everywhere around us, right? That bedrock, that is certainly a source of this arsenic in the well water, right? Because one of the ways we get water, we stick a pipe down into a crack between two granite parts of the shelf. Water has trickled down in there, and you just draw that water out. It's been sitting in there for a long time, just sucking arsenic out of the rock. You drink it, and you get bladder cancer. Right. So the question that led the group to was, if bedrock affects arsenic concentrations, does the depth of a well affect the amount of arsenic in the water? And sadly, the CEPA dataset does not have explicit well depth data. They need to fix that. But it does report on what type of well that the water was drawn off of. There are different types of wells. I'll go through it in a minute. But that well type is a proxy. It means it indirectly reports on well depth because each of the different types of well has a characteristic depth range. So here are the types of wells. There's really three. There's drilled wells, driven wells, and dug wells. The drilled wells are by far the deepest. And the drilled wells are anywhere from about 100 feet. If you're going to pay somebody to come out and drill a well, you're probably not going to have them drill a well that's less than 100 feet. All right. So it's 100 down to, you can send it thousands of feet down, right? You can drill, you can keep on drilling until you hit lava. Or you can have a driven well. And a driven well is basically just this spike. So the thing about a drilled well is it involves bedrock and you're drilling through rock. You're going down, you're drilling through rock until you find a pocket of water down in the rock somewhere. Driven well is basically just the wellhead is just a spike that gets pounded into the ground. All right, and this takes water off of the surface, like aquifer water near the surface. Usually not the bedrock, because when you're banging it down, it's hard to bang one of these things through the rock without drilling through the rock. These types of wells are easily contaminated, for sure. These are less easily contaminated because there's a sleeve and the way the whole thing is built. But if there's contaminants already in the water, it's obviously susceptible to that. So driven wells are between 30 and 100 feet. And then a dug well, that's just like dig a well. The like old, Jack and Jill went up the hill to fetch a pail of water, and, there's just like a hole that somebody dug in the ground or whatever. It's a dug well. And those are usually like 10 to 30 feet. Maybe there's a lot of water down there, and you dig a well, and the water's right there. So shovel or backhoe, usually lined with stones. People do drink out of dug wells here in the state of Maine. Large diameter, shallow, not cased, continuously, easily contaminated, and does not involve bedrock. You're not digging through bedrock. Okay, so these are the three types of wells: drilled, driven, and dug. What do you predict? What are your predictions before I tell you? Alexi, you were thinking? You looked like you were about to say. What would you predict if you were to guess? Which would you guess of those three would have the highest? Just take a guess. Drilled, why? Okay. So you're going to guess that drilled wells are going to be high in arsenic because they're going into the rock, which I've already sort of indicated is a source of arsenic. Arsenic compounds are in them.
I would actually well,
Okay. Easily contaminated by what? By how? Is it going to be easily contaminated by arsenic in the rock, or is it going to be where might the arsenic? Something, the shovel, okay, something from the surface. What were you going to say? Okay. Any other thoughts? It's not, I'm just giving you guys a chance to think deeply about it before I plow on the story. Sreni, what do you think if you're going to predict? Here's a question for you. How far down does dirt go? Topsoil. How deep is at most? At most. If you dig down beyond 40 feet and you're still in dirt, that's below that, it's usually some or like crushed gravel. All right. So here, let me show you. Here are the arsenic levels by well type, and and I'm separating them out: drilled, driven, and dug. And it turns out across the entire SEPA dataset that, and what you see here, this is numbers going in this direction. So at this level, there's a high number of wells that don't, driven wells that, or drilled wells that don't have any arsenic. But these are all ones that do have arsenic, right? So at this level, there's a stack of them. The red line shows the mean. Is it the mean? Yeah. The red line shows the mean for that type of well. And the red arrow is the EPA limit. So across the state of Maine, the mean value of arsenic in wells is above the EPA limit. That means, on average, you are likely to have well water that is 10 micrograms or higher. Driven wells, nobody home, nothing. There's a little bit of arsenic in some of them, but not anything significantly above the EPA limit. But damn, yeah, what?
See, there's less dogs.
No, it just means that there's more drilled wells than driven wells in our sampling, right? I mean, you're just sending people out with tubes to collect water, and there's just more people that have drilled wells than driven wells. To have a driven well work, you need to be somewhere where there's a lot of surface water, right, for the driven or the dug wells. So like driven wells work well if you're near like a stream and you're tapping alluvial water. That's like water. So when you see a stream, the water that's in the stream isn't just the water that's in the stream. It's also the water that's under the rocks and under the ground that's flowing along with the water that's in the stream. An underground component to a stream or a river. And that's often what driven wells are. They're like tapping into alluvial water from whatever source in a watershed. Just like if you go to the beach and you're on the sand and you dig down in the sand, you dig down far enough, you're going to hit water, right? There's water down there under the sand. But surprise, surprise, who said this? This was you. Yeah. the dug wells have a number of wells that have pretty high arsenic. In fact, some of them, one of them there is like the outlier is like 100 parts per billion. That's pretty high. It's pretty high. So what the hell is going on? Why are driven wells not giving us any arsenic? And drilled wells, we understand. We have a model for understanding that, the geology, right? But we don't have a model for really, a good model for understanding where the arsenic's coming from in these dug wells. What's that?
Materials.
That's right. So we're going to call that anthropogenic or human sources. All right? So the drilled well, that arsenic down there is coming from geologic sources, and then the dug wells are from surface water, anthropogenic sources of arsenic. All right, that leads us to another question. Well, okay, before I flash that question, hopefully no one read it. What is the next question that you would ask? Yeah, Jacob.
Oh no, I was just scratching my arm.
Heard that at dug wells.
Yeah. Dug wells have a little bit more arsenic in them than driven. Well, they have a lot more than driven wells.
So the next one would be dug well related.
Sure. What might it be?
Drill well, bedrock, dug well.
Yeah.
Right,
What?
like
And
what?
so human sources. What? And what's the next question?
Which sources?
What are human sources? Thank you. That's the question. What are the various anthropogenic sources of arsenic? And then more, which of them are the most likely to be affecting water in Maine? That's the next obvious question to ask. So these are they. These are the sources of anthropogenic arsenic. This is arsenic pollution that humans cause. So it comes from pesticides and herbicides, mining, the smelting of gold, lead, copper, and nickel. Leachate, meaning stuff that's leached out from abandoned gold mines, is a big one. Abandoned gold mines are super nasty and toxic. This is why I wear jade as a wedding token rather than any gold or diamonds. Both of them are blood-soaked industries. Wood preservative. So a wood preservative such as copper, chromium, arsenic, CCA, pressure-treated wood, green wood. The industry of producing green wood is super toxic. I mean, if you think about it, you're treating some wood with chemicals so that nothing wants to eat it, right? No bacteria are going to break it down. It's toxic-ass shit. Do not play fetch. So this is an anecdote, but I had a friend, or I was a coworker. He was a carpenter when I was a carpenter. He played catch with his dog once with a chunk of green wood, like a scrap of green wood, and the dog got like the nastiest sores in its mouth, like blistery, pus-filled things in the dog's mouth. It got copper, chromium, arsenic poisoning.
But why there are dog toys?
He was a carpenter. Wallpaper and wallpaper paste is another source. Old wallpaper paste used to have arsenic in it. And there's an interesting story about a U.S. diplomat to Turkey. It was the U.S. diplomat to Turkey. U.S. diplomat to Turkey. She took her office in the consulate there in the capital, and it was old. It was crusty. It was Turkey, and there was wallpaper that was crumbling, and there was like this wallpaper dust was everywhere. She quickly developed pneumonia. Arsenic incurred pneumonia, tuberculosis, and lung cancer. She got lung cancer from just being around this this stuff. She had to like quit her post and come back to the United States because she was exposed to arsenic and wallpaper. Iron and steel production, combustion of coal. There is the indirect effect of road salting, and then tobacco smoke. These are like ways that arsenic people get exposed to anthropogenic sources of arsenic. Which of those are a problem in Maine, would you guess? Yeah. Wood preservatives. We don't actually burn a lot of coal in the state of Maine, but we do burn some, yeah? Hell yeah.
Yeah, I was wondering how that works, how it affects our...
Hold on to your hats. Okay, so these are really the big ones in the state of Maine, actually. Coal is not a huge one in the state. We just don't have a lot of coal here. We don't burn a lot of coal. The Maine pretty much buys its electricity or generates it using like natural gas. Pesticides and road salting. We'll get into road salting. I'm going to tell you a story about pesticides that are particular to Maine. They used to have, these are all postcards, these are photographs of people in Maine that were spraying arsenic-containing pesticides right on the land. So they're growing potatoes. That's a potato farm in Aroostook County there. Apples in Berwick, Maine. And those funny ladies getting sprayed down, I think wouldn't think it was so funny if they had a chance to sit through this talk. Let's start with the pesticides. So this is really a story about this guy here named Etienne Leopold Trouvelot. He was a Frenchman, obviously, who was interested in the production of silk. But he split France. France was going through political upheavals. There was a coup d'etat in 1852, and he G'd out, moved to Medford, Massachusetts. But in his suitcase, this guy brought some gypsy moth egg cases that he was hoping to use to produce silk. He wanted to make silk out of these gypsy moths. Well, sadly, the gypsy moths and the brown-tailed moths, also from Europe, escaped from the enclosures that he had them in. And they ran frickin' havoc over the entirety of New England. They ran through New England, chewing up all the apple orchards, just like eating leaves, killing trees, messing things up. Super duper bad. And, one of the things in terms of like invasive species was a problem because humans were able to migrate before they fully understood the ramifications of biology, the biological ramifications of it. So this guy came in 1852, and The Voyage of the Beagle was just published in like 1851 by Charles Darwin. Right? So biology wasn't really there yet. There were all these amateurs that didn't know what the hell they were doing. So they tried to deal with it, right? They did everything from pick the gypsy moths off by hand. They'd set whole orchards on fire just to kill them. But it turned out, so like here, look at all those guys climbing up in trees, picking out gypsy moths. What a pain in the ass. But it turns out that the use of lead arsenate as a powder that was spread over the crops with an air compressor was the most effective. And it just like went into widespread usage. You have an apple orchard, you spray it down with lead arsenate. And arsenic is not good for you, but what else isn't good for you in there? The lead is not good for you either, right? So neither of those things were wise choices to be spread on the apple orchards around here. So this went on for a long freaking time. It went on for a long time. And it really hit its peak between the 1920s and 1950s. They hadn't fully appreciated the ecological disaster. So here's a picture from sometime in the 50s on the right-hand side, and they're still spraying potatoes down. They have been doing this for over a century at this point, right? Because Trouvelot came and peed in the punch bowl back in 1852. It wasn't even outlawed until into the 80s. I think it was like 1983. Before, smokes! My computer's about to go. Juice. Of course. Horse is a horse. Can I pick you off there?
Yeah.
No, you know what? You stay in there. Unplug that black thing. Okay. Okay. So, yeah. Fun story. So, anyways, they finally figured out that this was a problem. So,
What was the slide before say about like treating it with before that? Yeah, give sweet oil, butter, or milk. Hydrate.
I don't know. Just try to prevent absorption, flush it out. I don't know. That was like.
That actually works, or is that just something they said?
I would definitely give an emetic. Yes, an emetic is medicine that makes you vomit. Get as much of the crap out of you as you possibly can. I don't know about milk, but oil or butter is going to prevent absorption and make you crap. It's gonna act as a laxative. So whatever's in there is going to help flush it. So it probably works. Hydrated oxide of iron. That I don't know whether iron oxide. That's basically rust. Wet rust slurry. I don't know whether that's actually going to take up any arsenic or not. Yeah, Lance.
So that's why the topsoil dug wells.
Yes, sir. So the spraying of arsenical pesticides was super common through the 1940s and 50s. The residue of this arsenic on the apples was such a problem that they had to run the apples. You see them here. They had to be run through acid baths to remove the arsenic from them. To be able to dissolve the arsenic, they had to run them through mild acid baths to clean them up. But, 88. It wasn't even banned until 1988.
31 years.
Yeah, 1988. I was 15. I was in high school. I was your age in 1988. That's pretty messed up. So here is a case study about this thing called land scraping, where they would they were trying to remediate this land. These developers had bought this old orchard called Barber Orchard, and the orchard was defunct at this point. They wanted to build a bunch of houses amid the old orchard with the apple trees. It was going to be real quaint. They were going to make money. And then it turned out that there was wicked levels of arsenic all over the place. This is down in Carolina, I think. Yeah, North Carolina. And it turned out to be a Superfund site, an EPA Superfund site. So EPA has this giant pot of money that it uses to identify super toxic messes that were made and try to clean them up so that they don't fester, get more problems. So the subdivision, all these people were getting super sick in this subdivision. They tested for arsenic, oh shit, we've just been poisoning ourselves. And so they did this cleanup by removing the soil, land scraping. So they started pulling all the soil. They basically cleared the entire site of all of the topsoil. Can't shoot that stuff into space. They had to stick it somewhere. It went into a landfill elsewhere. But in the meantime, the project stalled out because imagine how much money it would take to scrape a neighborhood down 30 feet, the entire neighborhood. A lot of money. So they actually ran out of Superfund funding, and the project's on hold. Okay, wait. So, what is the next question you might ask? Are we done? Yeah. All right. I guess I'll pick up there next time. But what I want to do is, I'm telling you this because I want to get you guys going so we can make an announcement to the school. We have to make a form that we'll hand out to them. We need to update the form. And we're going to hand out tubes and forms and then all this other stuff. I just got this thing in the mail yesterday. It's got updated stickers and magnets that will have numbering for all the samples. And we're going to announce it at lunch. Anybody who's got well water in the school, if they want it tested for free, just go home, get a sample of the water, close the tube up the way that we give them on the instructions, and then fill out the form and bring it back in, and we will test it for them.
Literally just tap water?
Tap water, yeah. It's easy. It's super easy. If anybody wants their wells tested, right? So, and anyone in the class, obviously, but I'd like to get 50 wells out of this school. There's got to be 50 people, or in people's extended network in your neighborhood. That whole business. All right, that's that. We'll see you.